Okay, students, let starts our second lecture. So, in today's lecture, what I am planning to give an introduction to the per unit system. Although the per unit system in the syllabus it is not mentioned, but I strongly recommend to go through these in diploma level itself, because in future it is very much needed, because all the power system analysis always done in a per unit system. So what is per unit system? If you want to say, in the lecture notes you will find this one I am talking about, the per unit system. This topic we will be going to discuss. So what is per unit system? In normally, suppose we will take a small example. Suppose in a class, class A, या फिर you consider the class electrical engineering. Suppose electrical engineering class, there are 10 students who got job, and in civil engineering there are 10 students who got job. But if we don't know the strength of students in both the sections, we cannot compare the employability of both the sections. Suppose electrical there are only 20 students, out of 20 10 got job, and in civil suppose there are 100 and out of 100 only 10 get job. So you cannot compare this absolute value 10 student got jobs, because the percentage is different. Here out of 20 10 got jobs, so 50%. Here out of 100 10 got jobs, so 10%. So there is a difference between these employability. So the absolute value doesn't give you the clear idea. So in power systems also there are large number of systems which are interconnected, and all the machines has their own rating and different ratings. So when you interconnect them, so we need a common base, so that on that base we will compare all these value, so that we can draw a single line diagram, and we can utilize our normal circuit analysis in that network. So in percentage we take on 100. Here per unit means we consider per unit per one we are considering. So here what we've done in the power system, we take a base value and we compare the actual value with respect to that base value, and the base value is common throughout the entire system, means for all the equipments the common base is considered. So so let us go through some of the formulas here given. I will try to discuss this as simplifying as, so that this formula doesn't create any problems to you. So here you will see, this is the first definition they have given. The per unit value of any quantity is actual value of this quantity divided by base value of the quantity. Now in electrical, out of these four, V, I, Z or volt ampere, if you give any two, the others, all the value parameters you can calculate using any two of this one. So generally kV or kVA it is written, somehow it is kVA, you can write it MVA. The unit doesn't make any sense as long you don't do any mistake with what is kilo, what is mega. I will analyze that. I will explain that portion in later part. So you will see the kVA per unit is kVA actual by kVA base. While you will solve numerical, you will find it very clear. Just you go through the formulas here, I will give you the idea. And here it is MVA is equal to MVA actual by MVA base. So these two we have considered fixed. So according to this we will calculate the other values, that is V is fixed and VA is fixed. So these we will consider, and then we will calculate that. So first one is I, then Z, we will calculate one by one. So for I, what will be the base current? If I know the kVA base and VA base and volt base, so VA by volt will give you the I. So here two formula is given, so don't get confused. It is kVA by kV. Here kk cancels, so your IB, the base current, is only in ampere, and here it is MVA by K. The MVA is 10 to the power 6, K is 10 to the power, so it is kilo ampere. The unit is here kilo ampere. The difference is that only. So what will be per unit current? Per unit is again actual current divided by base current. So IA into IA means it is actual current divided by KB base. You can see it from here, the base current. I am putting the value of base current only here, KB base by kVA base. So what is the unit what is the unit will be of this IA? It will be simply in ampere. simply in ampere, because I have given kVA base by kV base, this one we have substitute. If we had substitute kilo ampere, then Ia should be in kilo ampere. So if we will continue this one, go to then base impedance. What is base impedance? Base impedance is V base by I base. Again you can see the V base by I base. So two formula are given side by side. One is considering kVA as a base, one is considering MVA. So I prefer you go by any of these one method. You go by MVA, then this 1000 will not come. So because k square divided by below there is 1k, so 1k need to be replaced, so that's why 1000 comes. This is nothing, don't get confused here. This is VB is equal to I will draw it first. I will do it in. Okay, so if we are seeing here, what is base impedance? Base impedance is V base by I base. Suppose I am writing V base as kV base. I have chosen kV as a base. So in case of I base, you will see there are two formulas in the I have already mentioned. One is if I write kVA base by kV base instead of I base. So what I am doing, what is the unit here? I unit is only in ampere, but here voltage is in 1000. So to compensate that, I am giving 1000. You are getting it now. This is the current I base. This is the current I base. This units is in ampere only, but here this units is in kilo. So to nullify that one, this 1000 came into the picture. So it becomes kV base square divided by kVA base into 1000. This problem will not arise if you take MVA base. There are another formula for I base. So if I use that one, kV base by, that is I base what? In MVA I have given MVA base by kV base. So what happens here? The I base itself, this itself is in kilo ampere. So it is kilovolt kilo ampere, so no need of 1000. So you can go by this one also. So there is no confusion of 1000s or something like that. So I will prefer you remember in either way, just you take care of unit. You give mega means 10 to the power 6, kilo means 10 to the power 3, everything will be automatically cancelled out. So you can see this one, both these are given in your notes. So here it is. You can see here both is given. This is what that one, and this is using MVA. So both the options are there. So and both are equal. So if you take now per unit impedance, what will be per unit impedance? Z actual by Z base. What is Z base? Z base you can use this one, you can use this one, either way you can this one. So it will come. Now what is Z per unit? Now coming to this portion, the portion I am talking about, that is this one, Z per unit new. This portion is means already Z per unit is given in old values base. You want to go to new base. So for that also I would like. So this one Z per unit new I want to calculate, and what is given? Z per unit old is given. So what is Z per unit new will be what is the actual value of Z divided by the base value of Z in per unit. We always know actual by base quantity. Now what is Z actual? Z actual is not given. What is given to you? This is Z per unit old is given. So from that, if you want to go, what will be the Z per unit old multiplied by Z base old divided, instead of this I am writing, and the lower is already Z base new. Always actual is, you know, the per unit quantity is equal to actual by base, so actual will be equal to per unit into base. So you just replace the values, nothing else. So it will be Z per unit old multiplied by what is Z base. For Z base I am using this one, this formula. There are two formula. It is one is using 1000, one is without 1000. If I choose MVA, so it will be better. So this complexity will not come over 1000 if we go for MVA. So what is Z base? It is kV old by MVA old, kV old whole square by MVA old into what will be this one, kV new whole square divided by MVA new. So if you do a little bit modification, so you can so if you do a little bit modification, you will find it is Z per unit old multiplied by MVA new base I am not writing here, or MVA old divided by KV old by KV new. So what is this formula? A very important formula, this one is, suppose a per unit value is given but a different base it is given, you want to change the base, you want to go a new base system. So this one, so how to remember, there is a method I used to tell in the class, that is new old, you remember in this way, and the square is in last, KV square. So new old formula. So now what is the advantage? I have already told you, it gives you more meaningful expression, and the one of the most useful is the elimination of the transformer. Means transformer primary side there will be one voltage, secondary side it will be different voltage. The beauty of the per unit system is that when you draw the single line diagram, this transformer you can eliminate, because the per unit value in primary side equal to per unit value in secondary side. So there is a little proof of this one. I will do it here itself. So you know in transformer Vp by Vs is equal to Ip by Is. This one, Is by Ip. So Vp Ip is equal to Vs into Is. Both side Va should be same. So Vp is the primary voltage and secondary voltage. Suppose Zs is the secondary side impedance if I am writing in secondary side, and Zp if I am writing in primary side, then it is primary side, because in either side you will write, either in secondary side you will write or in primary side. But there is a relation between these two. Both the side you cannot write whatever you think. If secondary side is 5, then primary side there is a relation. What is the relation? You know already. Zp by Zs is equal to Zs into Vp by Vs whole square. That is k square, that factor you used to remember by n1 by n2. So if you see the derivation, what is Z? Suppose I am calculating for primary side per unit value. So what will be primary side per unit value? It will be Zp, that is primary side actual value, divided by your primary side base. What is primary side base? Vp by Ip. That's why Ip is in the above. So if you now you replace the value of Zp from the above equations, you can find Zs into Vp square Ip by Vs square into little bit mathematics, you cancel Vp, it will come Zs into Vp into Ip by Vs square. And what is Vp into Ip? It is Vs into Is, you know, all in case of transformer. So finally it will come Zs into Is by Ib, which is also Is you can take below, Bs by Is Z base. So what is this is given? This is nothing but this portion is Zs secondary side impedance in per unit. So this is your primary side impedance in per unit, this is, so both are equal same. This portion they have done in reverse way, that is from Z secondary per unit they are coming to primary per unit. So this is an important derivations if you can think of to show that the primary and secondary per unit reactance or impedance in case of transformer is same. So that's all.